Hello YouTube Reloaders! Thanks for watching. Hornady Loader here. My standard disclaimer, I am not an employee of Hornady Manufacturing, nor do I have any interest financially or otherwise in the sale of Hornady products. I've been reloading for almost 35 years, and for the last 20 years I've been using Hornady equipment almost exclusively, hence the name Hornady Loader. The Hornady logo is a registered trademark of Hornady Manufacturing, Grand Island, Nebraska. This is the first of a series of videos that will take us on a journey towards the development of a match-grade load for my Remington 700 SPS Tactical AAC-SD rifle, chambered for .308 Winchester. I've been preparing this rifle for competition. The rifle's ready. Now it's time to produce accurate cartridges that I can use in high-power rifle competitions. All of my previous videos have been preparing for this video series. I won't be going into how each device works in this series. For that, you can refer to my previous videos. For this series, I'll be concentrating solely on the process of developing a match-grade load. I'll only go into detail on a particular device if it will be used in a different manner than in my earlier videos. This series will consist of 3 phases. In phase 1, we'll have 2 objectives. 1, we need to fireform some cases. We're going to use some new Hornady match cases, as well as some Winchester factory cartridges. That'll give us a couple of different kinds of cases to play with. Secondly, we want to create a control group. We're going to use some basic reloaded cartridges that we use the Hornady match cases for, and we're going to use the Winchester factory cartridges. We'll be measuring velocities and group sizes, things like that, and get a control group for some basic loads that we haven't loaded specifically for accuracy. This will give us a base point and enable us to compare the control group with our final product at the end of the process. Now for phase 1, we're going to use some minimal reloading techniques. We're going to full length size and trim the cases only. We're not going to be checking the neck wall thicknesses and turning the necks and bumping the shoulders back, things like that. We're just going to use SAAMI standards. Since we don't have the information we need without the fireform cases, we'll have to use SAAMI standards for loading our initial set of loads. We're going to use the auto-progressive press just to get this process through a little bit quicker rather than the single-stage press. Typically when I load for accuracy, I use the single-stage press and I monitor each individual activity. But for this, since we're only really looking for fireform cases, I'm going to use the auto-progressive. We're also going to use custom grade dies as opposed to the match grade dies. The match grade dies give us the ability to size the neck exactly the way we need it based on the size of our chamber in the rifle. Since we don't yet have fireform cases, we don't know what that size is. So we'll just use the custom grade dies, and that'll size the neck down to SAAMI standards. We're going to use a powder measure as opposed to a powder scale. Since we're using the auto-progressive press, using a powder scale with an auto-progressive press is a little unwieldy. So we're going to use the powder measure to drop our charges. Once we've loaded our cartridges, we're going to spend some time at the range. We're going to measure groups and velocities for our reloads and for our Winchester factory rounds, and get that control group. And this will give us the 2 different things, the 2 different objectives that we need for phase 1. Fireform cases and a control group. Phase 2 is going to be our initial accuracy load. We're going to switch over to the single stage press, and we're going to use our match grade dies. We're going to use a variety of powders and charges. We'll use a variety of bullets. For this experiment, we're going to use 168 grain Hornady match bullets, 178 grain Hornady AMAX bullets, and some 168 grain Sierra match kings. We're going to use our full complement of case tools. We're going to turn the necks. We're going to pump our shoulders back a couple of thousandths. We're going to make sure our primer pockets are of a uniform depth. We're going to pull out all the stops on setting up our cases. And we're going to switch over to using a powder scale to get more precise powder charges. We want every cartridge to have exactly the same powder charge so that we can get more consistent shots out of it. And we're going to, at the end, we're going to do a concentricity check to correct any run out that we have in our between our bullets and our cases. Phase 3 then will be kind of a fine tuning. We're going to play with bullet seating depths. We'll start out maybe at 30 thousandths or 40 thousandths, something like that. We'll create a batch of 10 at 30 thousandths, say. We'll create another batch of 10 at 25 thousandths and go down all the way down to maybe 2 or 3 thousandths. The measurements being from the ogive to where the bullet would contact the rifling in the bore. Different rifles like different bullet seating depths, a different amount of a running start before the bullet hits the rifling. So we'll find out what my particular rifle likes in terms of bullet seating. We'll try different primers, Winchester, CCI, tool ammo, and see, if any of those make any significant changes in the accuracy of our cartridges. We'll also try some cases. Now we're going to be fire forming Hornady match cases and some Winchester cases. We may also try some Federal Remington cases. We'll play around with the cases. Now it's important here that we only make one change at a time. If we change the bullet seating depth, we change our primers, and we change the cases, and that makes a difference in our accuracy, we're not going to know which one of those three things had an effect, or if it was a combination of those. So we're going to do one thing at a time. Change the bullet seating, do a batch like that, and maybe change the primers, do a batch like that, so on and so forth. And then we'll rinse and repeat. We'll repeat phases 2 and 3, maybe with a completely new set of components, and see what that gives us. After all, the quest for accuracy is never ending.